Okay, when we left off last time, I had asked you to answer these questions on your own. So welcome back, and let's take a look at this. Questions for section 4. What is magnetism? Well, magnetism is the properties and interactions of magnets. Okay? So when we talk about the properties of magnets, they align domains, the magnetic field that they exert around them, okay? And then the interaction, what happens when you bring two magnets together, how do they affect each other? What is a magnetic pole? It's the end region of the magnet. The magnetic field is the strongest. Remember, we talked about water was polar, one end was positive, the other end was negative. All year I've been saying anything with poles has a positive end and a negative end. Well, here we go. Magnets have poles. Okay. And this is why other things are called polar, because they end up with a positive end and a negative end. And what is a magnetic domain? It's a group of aligned atoms that create the magnetic fields. Okay. Like poles repel, unlike our opposite poles attract. Where is the magnetic field the strongest? Closest to the magnet, poles. So this is where this unit comes together. It's just called electricity and magnetism. Okay, remember an electric field is that field that's created around any current carrying coil of wire. So we saw how it affected those iron filings. And then we have a magnetic field, which is the area around a magnet. It has a attraction between positive and negatives. So if you put the two together, electrons in the wire are going to be attracted to the positive end of a magnet, and they're going to start moving through the wire. Well, when electrons move through a wire, that's what electricity is. So if you take a magnet and put it near a wire and start moving it around, you actually can make electricity. So this electromagnetic force is the connection between the relationship between electric fields and magnetic fields. There is always an interaction between electricity and magnetism. Moving charges create a magnetic field around them, like we saw with that wire. A moving magnet next to a coil wire produces electric current. Okay, that's because the electrons in the wire are going to be attracted to the positive end of the magnet and repelled by the negative end of the magnet. So they're going to begin moving in the wire to get away from the like pole or move towards the unlike pole. So, and when the electrons start moving in the wire, they're going to create an electric current. Okay, the electrons always move towards the positive pole and away from the negative pole. Moving electrons is electric current. Okay. An electromagnet is a temporary magnet. And the reason why it's temporary is because if you unhook it from the electrode part, it's no longer a magnet. So here's a picture of an electromagnet, and it shows we got this nail. Remember, it has the jumbled up atoms in it. They're not in a domain. And then we wrap this wire around it, this current carrying coil of wire. And when we hook it to the battery, okay, the wire creates an electric field around it. The electric field is a magnetic field, okay? It has the properties of a magnetic field around the wire. That affects the atoms in the nail. The atoms in the nail are going to start to line up according to the poles of the field created by the wire. So the atoms in the nail are going to align into domains, and the nail is going to become a magnet. That's why it's called an electromagnet, and it'll stay a magnet as long as there's electricity running through this wire. Now, let's use some common sense. Since the electromagnet is created by the electricity running through the wire, then it seems kind of obvious that the more electricity we run through the wire, the stronger the magnet. And it's also created by wrapping this wire around the nail. So the more times we wrap the wire around the nail, that would also make the electromagnet stronger. So let's take a look over here in the notes. It says a moving electric current turns the iron into a magnet, amplifying the magnetic field produced by the current. only present or magnetic when electricity exists only while the electricity is flowing. Increasing electromagnetic strength, making it stronger. Okay, like we just said, you can add more turns to the wire. Okay, so the more times you wrap the wire around there, okay, the more times the electricity has to create that magnetic field in the wire. And then since it's created by the electricity, adding more current or electricity also makes it stronger. So the magnetic field around each one of the coils would be stronger depending on how much electricity is running through there. Changing the direction of the current will switch the magnetic fields. So if we turn the battery around, then we would switch the positive and negative poles of this electric magnet. So an electromagnet, unlike a permanent magnet, can change its north and south pole. The south pole can become the north pole, and then the north pole can become the south pole. So that's real important to understanding how an electric motor works. An electric motor is a device that turns electrical energy into mechanical energy. Okay, so an electric motor is a device that turns electrical energy into mechanical energy. So electric motors usually make things spin or turn. Okay. Now, I had just explained that an electromagnet can change its poles. And this is really the key to making an electric motor work. Okay, so it contains an electromagnet that's free to spin between a permanent magnet. The coil electromagnetic magnet is connected to a source of electricity. So over here, we have kind of a really crude electrical motor. We have the permanent magnets here. It has their positive in and negative in. And there's another one with a negative and positive. And then we have a nail with wire wrapped around it. So it's going to become an electromagnet. And the nail is on an axle, so it's free to spin around. And then we're going to have some electric current moving through it. When the electric current moves through the electromagnet, it creates a magnetic field. Okay, this will spin the magnet so that the like poles repel and the unlike poles attract. Unlike a permanent magnet, the poles of an electromagnet can be changed by changing the direction of the current. So now we need then to be able to change the direction of the current. So there's a switch in an electric motor called a commutator. The commutator is a device that reverses the direction of electricity. This then spins the magnet in the motor since the like poles are always next to each other and repelling. The commutator continues to flip-flop the poles, keeping the magnet spinning. So let's take a look at our motor over here. I'm going to put a battery in here. When we do that, the current is going to flow. And so positive is going to be flowing to the negative. Okay. And because the positive flows to the negative, this electromagnet is going to become positive on this end and negative on this end. Okay. And it's going to repel. Okay. The like charges are going to repel between the electromagnet and the permanent magnets. So it's going to try and turn. Okay, this positive wants to get over here by this negative, and this negative wants to get over here by this positive. So it gets over there. Okay. And the negative is where it wanted to be, and the positive is where it wanted to be. But now the battery changes direction. And then the poles change. And this becomes the positive again, and this becomes the negative again, and they repel. And then it gets to where it wants to be. Okay. And as soon as it gets to where it wants to be, the battery changes direction. So now that this becomes the positive, this is what the commutator does. Okay, is it switches the direction of the current. So now we got the current flowing here on the positive side, and this is on the negative side. That makes this a positive end. This makes this a negative end. The like poles repel, so that magnet turns. It gets to where it wants to go, and the battery switches the current. So now this becomes the positive again, and this becomes negative. That means the poles of the battery switch and it repels. So it's kind of like a cat chasing its tail. As soon as it gets to where it wants to go, the electric current changes direction because the commutator, and then the battery or the motor just keeps spinning and spinning and spinning. We're going to take a clip, look at this clip of a motor versus a generator.
This is a very simple and basic structure of an electric motor. We can see the battery, the commutator, the brushes, the copper wire loop, and the permanent magnet. The brushes are attached to a wooden support, and the commutator is fixed to the loop of copper wire. The commutator rotates freely, rubbing against the brushes. Now, when we pass current through the circuit, this creates a magnetic field around the wire, which interacts with the field of the permanent magnet to produce a rotation of the loop that looks like this. The electric motor and the electric generator are related like two sides of a coin. In general, the task of an electric motor is to convert electrical current into mechanical force. On the other hand, an electrical generator converts mechanical force into electrical current. So as you can see, we can simply rearrange our motor into a generator. In this case, we will provide the mechanical force with a windmill rotor attached to the loop and connect a bulb in place of the battery. We will leave the magnetic field as it is, and as the wind rotates the blade, an electrical current is produced.
All right, so here's this picture of an electric motor, and it shows the commutator here, okay, and what it does is it has a contactor on one side, and one side's covered with an insulator, so as the electromagnet turns between these two permanent magnets, the electricity goes one way, and then it goes the other way, and then it can flow one way, and then the other way. Now, an electric generator has all the same pieces that a motor does. The difference between a motor is you have the electricity, and that makes the electromagnet turn. With the generator, you turn the electromagnet, and it makes the electricity. Remember, whenever there's a current, a wire that can carry current inside of a magnetic field, if it's turning, the electrons in the wire are going to try and get to the opposite poles. So they're going to start flowing through the wire. As they flow through the wire, they make electricity. So it's just an electric motor. The only difference is an electric motor gets the electricity and turns the electromagnet. In a generator, the magnet gets turned and makes the electricity. So a generator is a device that turns mechanical energy, like this guy's hand turning the electromagnet, into electric energy. Okay, so I put in here to add into your notes, okay, is the same thing as electric motor in reverse. The motor uses electricity to turn the magnet. The generator magnet is turned to make the electricity. So just like a motor, it contains an electromagnet that's free to spin. An outside source of energy is needed to turn the electromagnet. This is why when we study what happens in a power plant, okay, it was the turbines. And so the steam would go past the turbine, or in a hydroelectric plant, the water would go past the turbine and make it spin, or if it's a windmill, the wind blows and spins the wind turbine. If it was the tidal energy, the tides go in and spin the turbine. So what they're doing is when they spin, they're turning an electromagnet. Okay. The outside source of energy spins the electromagnet, and the electromagnet spins, electric current is produced. The electrons in the wire are wrapped around the electromagnet, are attracted to the opposite poles of the permanent magnet and repelled from the like poles. This makes the electrons flow, which is the electric current. Power plants use generators to make electricity, which we studied earlier in the year. Moving water, steam, spinning turbines, water, wind are some ways to spin the electromagnet. And the field and produce the electric current. We're going to stop here. This ends this year's, this is the last unit. I hope you're having a great day. We'll see you next time.